We're going to go through our planet notes, and you can pause the video as needed to be able to type or write the blanks into your own notes, and you can rewind to hear stuff if you need to. So, we're starting with how the Earth took shape in general. So we know that 4.5 billion years ago, the solar system started to form. So we talked about the solar nebula theory, where there was a cloud of dust and gas, and all of that was mixing together. Eventually, it started to flatten out a bit. The sun formed at the center, and then we had this mass of dust and rocks and stuff that was collected around it and spinning around it, and that was called the protoplanetary disk. So as that dust and gas did that, they would come together, and they were called planetesimals. So those formed, and Earth was among them. So planetesimals are just small chunks of essentially rocks and dust and all the stuff that made the planets, and they came together, and then more of them came together, so they formed larger bodies. And this took about 10 million years. So then the Earth was able to gain more mass. And as it gained more mass, so more of these planetesimals hit the Earth, it gained more gravity. And then over time, the more gravity caused it to become round. Also, as these planetesimals hit the Earth, their energy was heating up Earth's atmosphere and Earth itself. And also, there were radioactive materials that heated up the Earth. And this happened from the core, and it began to melt the rock that formed the Earth. So then we can move into how the layers were formed because of those two things that happened. So because all these impacts were happening and that heated up the Earth, and also because the radioactive materials decaying, which also heated the Earth, the materials were able to separate based on their density. So then the crust, the mantle, and the core were formed. So the dense iron-rich material sank towards the center, and that formed our core. The lighter rocky materials rose towards the top, and that ended up forming our crust and upper mantle. And then the lightest and coolest materials all floated towards the top. And I can bet you can guess what that formed. That formed our atmosphere. So that's how the layers formed. All the materials were different densities. They were all melted, and they separated according to their density. So that's why we have a heavy inner core made of metals and iron-rich materials, and then all the light gases floated outwards, and that formed our atmosphere. So we also have to talk about Earth's early atmosphere. So we'll just separate it into a first and a second, and then today's atmosphere would be our third or current atmosphere. So the first atmosphere was formed around when the solar system was forming. So the main elements then were helium and hydrogen. So that's what the first atmosphere most likely consisted of, since that's what was around then. And then the second atmosphere was made up of volcanic gases. So that would be the water vapor, carbon dioxide, nitrogen, ammonia, gases like that. Were formed from volcanoes. There was lots of volcanoes at that time. They released carbon dioxide into the air. The water vapor steam they released into the air, and all of this was just floating around in the atmosphere in much, much different concentrations than we have in our current atmosphere today. So that's how the early atmosphere formed, from gases that came from volcanic eruptions in the earlier days. So if there was hydrogen and there was helium, where did all these other elements come from, and how did they get to Earth? So the way that they got to Earth was because other planetesimals brought them here to Earth when they crashed into the Earth as the Earth was forming. So all elements, hydrogen and helium included, are formed when stars are born and as they grow. The heavier elements are formed when stars are essentially dying as they go through a supernova. So in some of these elements, they react together and they can form new elements. And that's where the periodic table of elements came from. All the elements are just organized there, but they were made from stars. So it's true that we all come from stardust. It's also important to know where the oceans inland came from. So, after all these volcanic eruptions I was talking about, and it released all this steam and water vapor into the atmosphere, eventually clouds were forming, and as the earth cooled and the temperature of the earth was below boiling point of water, um, rain collected in those clouds, and then it was able to rain. So all the basins that were made from the volcanic rock that had solidified were filled up with this rain, and that's how our oceans were formed. So the rainwater pooled over the molten rock and cooled it and helped it harden to form crust as well. So that's how we end up getting the oceans. For a couple 100 million years, Earth was essentially a water world covered with this rainwater that had fallen from the clouds that were formed from the volcanoes. And eventually, after many volcanic eruptions still happening after Earth was a water world, there was islands formed underwater. And then as the volcanoes kept erupting and erupting, forming these underwater islands, more land was exposed, and then that's what created our continents today. And then eventually that land began to break up because of plate tectonics. We're going to talk more about plate tectonics later in the year, but this convection currents in the mantle that are causing the plates to move apart, which is still happening today. The plates are still moving today, which is one reason that we have earthquakes. So that's how the oceans and the land was formed. So is there life on other planets? We know stuff about the other planets in our solar system because satellites that we send. So there are either 7 or 8 planets besides the Earth, depending if you count Pluto, that revolve around our sun. So some of these planets have moons and some of them have water, so why don't they have life? So we're going to talk about each of the planets, and we're going to compare and contrast why they may or may not have life. So we're going to start with Mercury. Mercury is the closest planet to the sun. One day on Mercury would be 58 Earth days. So the amount of time it takes Mercury to make one full rotation takes 58 Earth days. 1 year on Mercury, how long it takes Mercury to revolve around the sun takes 88 Earth days. Mercury size, it is slightly larger than our moon. If you were standing on Mercury and you looked at the sunlight would be 7 times brighter than it is on the Earth. Mercury is the most cratered object in our solar system. That's just because it doesn't really have much of an atmosphere, so there's nothing to burn up anything that's coming towards it. The daytime temperatures are 427 degrees Celsius, which is about 800 degrees Fahrenheit. Nighttime temperatures are about negative 290 degrees Fahrenheit, so it gets really hot and it gets really cold, mainly because it doesn't have an atmosphere. Also because it's so close to the sun. There are no natural moons for Mercury. So could it support life? Most likely not. We would almost say definitely not. There are currently 2 spacecraft satellites going towards Mercury. They will be orbiting around 2025. In the 1970s, NASA sent a satellite to Mercury, and it also went by Venus, and they collected data from there. So they lost contact with that satellite in 1975. And then in 2004, they launched a different satellite, which they then crashed into Mercury in 2015 once it was done with its mission. The next planet, Venus, this is the second planet from the sun. People call it Earth's twin because it's about the same size. There's many, many things that are different about it, though. One thing being its thick, toxic atmosphere. Mercury has a really, really dense atmosphere, and it causes heat to be trapped, which is why Venus is hotter than Mercury, even though Mercury is closer to the sun. So the average temperature of Venus is 867 degrees Fahrenheit because the atmosphere traps heat. Venus does rotate backwards, so the sun comes up in the west and sets in the east. A day on Venus, so the amount of time it takes to revolve around it, or rotate on its axis, is longer than the amount of time it takes Venus to revolve around the sun. So 243 Earth days to equal 1 day on Earth, and 224 Earth days to equal 1 year on as the same as Earth. Venus also has no moons. So the key thing here is that a day is longer on Venus than a year is on Venus. Earth, we're not going to talk a whole much about Earth because we'll get there eventually. Earth is the third planet from the sun. We know 1 day is 24 hours, 1 year is 365 days. The average temperature is about 58 degrees Fahrenheit, and we have one moon that is named Luna. Mars is the fourth planet from the sun. 1 day on Mars is 24.5 Earth hours, so pretty similar to our day. And then 1 year on Mars is 687 Earth days, so that equals about 2 Earth years. The average temperature on Mars is negative 51 degrees Fahrenheit, so it's a pretty cold planet. It does have water vapor and ice because it has polar ice caps. It does have extinct volcanoes, and it also has seasons. It does contain the biggest volcano in the solar system, and it has 2 moons. Mars has a very, very thin atmosphere, which is why it's so cold. And NASA currently has 3 satellites orbiting Mars, 1 rover on the surface, and 1 lander on the surface. Jupiter, this is the 5th planet from the sun. It is a gas giant, so we've switched from the planets we were talking about before were terrestrial planets. Now these are all gas giant planets. 1 day on Jupiter is 10 Earth hours. 1 year is 4,328 days, which is almost 12 years. So Jupiter's really far out there. It takes a long time for it to revolve around the sun, but it spins super fast, which is why it's only 10 Earth hours. The average temperature on Jupiter is negative 243 degrees Fahrenheit. There's no solid surface, which is why, again, it's called a gas giant. If Earth was the size of a grape, Jupiter would be the size of a basketball. So you can really see the size difference there. Jupiter does have a massive storm that's called the Great Red Spot. You can see it in this image right here. It is actually larger than the Earth. And Jupiter releases more heat than it absorbs from the sun. So there's lots of energy happening in Jupiter. And it does have over 75 moons. Our next planet is Saturn. This is the 6th planet from the sun, another gas giant made mostly of helium, hydrogen, methane, and ethane. The average temperature on Saturn is negative 301 degrees Fahrenheit, so super cold. Saturn is famous for its rings, has very pronounced rings. All the gas giant planets have rings, but Saturn is the most pronounced. There are about 7 rings, and they have gaps in between them. You can see one of the gaps in this image here. But these rings are made up of different ices, dusts, rocks, materials like that. 1 day on Saturn is 10.5 Earth hours, so spins pretty fast. But 1 year, it takes 29.5 years to revolve around the sun, so that's a long time. Saturn does have 82 moons. Then we'll move on to Uranus, which is how it's pronounced, Uranus. This is the 7th planet from the sun. It is a small gas giant. And Uranus and Neptune are known also as ice giants because they have a rocky core, but they have like a hot, dense fluid of icy materials, which sounds weird, a hot, icy material, but it's real fluid-like, and it's not a solid material. So it's still a gas giant, but also known as an ice giant. It does rotate on its side. That's just from an early collision when it was forming in the solar system. 1 day is 17 Earth hours. 1 year takes about 84 Earth years. The average temperature is negative 353 degrees Fahrenheit, and it has over 25 moons. Neptune, the 8th planet from the sun, known as the other blue planet, that's just because the chemicals